find the implicit functions. So what's our rule? How do we find the implicit functions? What do we need to do?
Isolate y.
Gotta get y by itself. So in this case, it's gonna be y squared. So we'll subtract the 2x squared over. Some of you like to put the 2x squared in front, which is fine. So if you have negative 2x squared plus 6, totally fine, doesn't make any difference. Once you get to y squared on its own, then what do?
Square root.
Square root. And when we square root, do we do anything to this ever? No. So y equals the square root of 6 minus 2x squared. Y equals negative square root of 6 minus 2x squared. Anything you do beyond this will be wrong. There's no i's, there's no simplifying it, there's no factoring it, there's no nothing. You just square root both sides and that is the answer. Okay? Now we've got the domain section. So, what's our rule? Or I should say, our 2 rules for domain. What?
Under a radical and denominator.
If it's under a radical, it has to be positive, or has to be greater than or equal to 0, right? So, under a radical, greater than or equal to 0. So there's my answer. Would you agree? We've done like 8,000 of these, right? We got this. No radical, no radical. Oops, there's another one. X plus 2 greater than or equal to 0, so x is greater than or equal to negative 2. All right, what's our other rule? Denominator cannot equal 0. Okay, no denominator, whoops. 3x minus 1 cannot be 0. 3x cannot be 1. X cannot be 1/3. No denominator, or I mean no radical, or no denominator, I guess I'm doing denominator. No denominator here, so x minus 3 cannot be 0, so x cannot be 3. Now, this problem actually has a 2-part answer, right? Both of these are the answer. Why? Because the problem has a radical and a denominator, and that's where you get your answers from. Now, what about this guy? I haven't written anything down for him. All real numbers, which we write as negative infinity to positive infinity. Why is that all real numbers? Because it doesn't have a denominator and it doesn't have a radical. Right?
So on the question that you just did with the denominators, you just not touch whatever's on the top.
Nope. The rules are radical, denominator. Don't care about anything else. Okay. Number 4. Now we've got our sketching problems. So this is where you really need to know your BFF shapes. Otherwise, you're not going to know what to draw here. What am I going to draw for the first one? What shape do I have here?
A V.
A V. The normal V is at the origin. This V has been moved. How has it been moved? Left 2, up 1. Very good. Make sure you label that point. Left 2, up 1. On your test, you get half credit for having the right shape, and then the other half credit for having it in the right spot. Okay. Now we got another toughie. We had one like this the other day, you remember? So I'm going to start by drawing my regular sine curve. And do you remember that it bounces back and forth between 1 and -1? That's your normal sine. Now think about this. It bounces back and forth between -1 and 1. What are we doing to it? Moving it up 2. So if we move everything up 2, now it's bouncing back and forth between +1 and 3. So here's 2, here's 3. So think about in the beginning, these aren't asymptotes, I'm just drawing them in. So you can see it bouncing between -1 and 1. Now, it's bouncing between 3 and 1. So the purple is the answer to the question. Does that make sense to you? You picked it, cut it out, picked it up, pasted it on. All right, what shape is C?
Parabola.
That's a parabola. How do we know it's a parabola? Squared. How's our parabola moved? It's not at the origin anymore. It has gone
Right one, down one.
right 1, down 1. Make sure you label that point and sketch in your parabola. What shape is E, or D, I mean D, this is,
I think
Oh.
D is in
I
parentheses.
skipped D. Sorry. I skipped D and wrote E. Let me put E, D over here. What shape is D?
Q.
So what shape is it?
Squiggle.
Squiggle? And normally the squiggle is right at the origin. What's happened to this one?
Left two.
Left 2. So now you're gonna have your same squiggly shape, but now it's gonna squiggle through that point right there. Right? Is that okay with everybody? All right, and then this guy, E. What shape is he? At the origin, up and out? But not at the origin anymore, where is he? Left 1 and down 2? So up and out from that point. Everybody okay with so far? All right, now we've got our piecewise function. So this is a biggie, but we can do it. What's the first thing I probably should do in terms of graphing this guy? Make my squiggly line. And where will my squiggly line be
-1.
at -1? So I'm just gonna make a real light squiggly line. It's not part of my picture. I should erase it when I'm done with it. But that's where my dots will be. Okay. So what's this first guy? Let's see, what shape? Just a line, and it's down 4, right? And has a slope of 3. So down starts here, and then up 3 over 1, up 3 over 1, so, blue. That looks, supposed to be a straight line. Not very good at all, but that's a nice straight line there supposedly. And, oh shooty tooty. Do you see how he intersects my squiggly line down here? So I should put a dot there where he intersects. That dot should be open. And then, what part of that line do I keep? Just that, right? So I'm sorry it's down there so far, but that's all I got. This little guy right down here is all I have left. Because this is all getting erased. So far I just got this little piece clear down here. Alright, what shape is this? That's a V, but it's not a normal V. It's a V that's been moved up one. Here's where it crosses. That dot is shaded. And I'll keep that side of it. So I'll get rid of this little piece right here. Now I'm going to erase my squiggly. Try to remember to do that. If you don't remember, I'm wrong. So I've got this like check mark up here, and then this little guy down here. Got it? And I have one more section and this test is over. Alright, so this is the section where I have to find horizontal and vertical asymptotes and holes. Alright, let's start with these first two. I need horizontal, vertical, and holes. Alright, what should I do first? Do you think? Well, first I should check to see if my problem factors. Because if there's going to be a hole, how will it happen? I'll have to cancel. And I can't cancel unless I can factor. So, does anything factor in problem one here? No. Which automatically means then there will be no holes. Do not cancel anything unless you can factor first. Okay? Now, tell me about these other things. Are there any asymptotes in this picture? Where's the vertical? From the denominator. So you know from our domain work that 3x minus 4 can't be 0? Yep.
Yeah, I just fell.
Will be to the people watching this video. Don't hit this shelf over here. This case is not worthless. You know, my old case, they never fell. It never fell. Ever, ever, ever. And this just is worthless. Okay, it's still going. All right. So, if 3x minus 4 can't be 0, then 3x can't be 4 and x can't be 4/3. Which means my vertical asymptote is at 4/3. Vertical asymptotes are what x cannot be. So when you say x cannot be 4/3, that's a vertical asymptote. What about horizontal?
2/3.
It comes from right here. So that's y equals 2/3. Y equals 2/3. remember, asymptotes are equations. So if you write just the numbers, you're gonna half off. Gotta have the letter, y equals x equals. All right, good deal. What about this one now? Same problem. You gotta find vertical asymptotes, horizontal asymptotes, and holes. Anything factor in that problem?
Two squares.
The top factors?
Yeah, two squares.
So x plus 3, x minus 3. Now, I could factor, but can I cancel? Which means I still have no holes. Because it's not the factoring, it's the canceling that gives you the holes, right? So we factor and cancel. We can't cancel, so we're done. All right. How about vertical? Are there any cannot be's? What can x not be? Negative 5, straight from the denominator. X plus 5 cannot be 0, x can't be negative 5. That means your asymptote's at negative 5. How about the whole boxing thing? I don't think it's gonna work, do you? There's no horizontal asymptote because when you box in, like we did here, you have to box in the highest power. Well, guys, isn't the highest power x squared? But I have none in the bottom. Can I have a 0 in the bottom? That's why there are no asymptotes, horizontal, no horizontal asymptotes. All right. And one more problem, and we're done with this test. 2x squared minus 32. X squared plus x minus 20. All right. Tell me what to do first. Factor. What factors? Oh, the top and the bottom, okay. So what can I do to the top?
Take 2 out first.
Okay, so if I take a 2 out first, then I can keep factoring x plus 4, x minus 4. Is everybody okay with that? I pulled a 2 out. Now, how about my denominator? How does it factor? I heard somebody say something, but I couldn't understand it.
That's plus 5, that's minus 4.
Plus 5 minus 4?
That's what it is.
Is that right? How do I check it if I'm not sure?
Foil it.
Foil it back. It's right. Stop, right? Okay, what do you notice? We can cancel out an x minus 4. Now, the fact that we can cancel out an x minus 4 means we're going to have a hole. And the hole will be where x is 4. The hole goes at the x value that you crossed out. So, if this were gonna be an asymptote, wouldn't it be at 4? Isn't x what it can't be? That's where the hole goes. 4. Now, how do I get the y? The hole is a point, so I need a y too. Where do I get the y? Plug the 4 in here. So 2 times 4 plus 4 over 4 plus 5. So what's that gonna give you? 16 over 9. 2 times 8. Now look at this guy. Are there any asymptotes? Where are the asymptotes?
X equals -5.
So we got a vertical at -5 because x can't be -5. Right? Cannot be our vertical asymptotes. Where's my horizontal?
2.
At y equals 2. And that one, kids, you could have gotten from the beginning of the problem, or you can get it here, 2x over x. Either place, it doesn't matter. Your horizontal asymptote is y equals 2. Okay? Now, I know we did part 1 the other day, but we just took 4/5 of the test. I mean, it's easy. All right, there's one more practice test, and it is like formatted. It's got the answer blanks, so it's all spread out. So this is exactly what your test is gonna look like. Maybe in a different order, but these are the problems. All right, so here we go. Eddie's putting his name on it. He's ready to rock and roll. Take a minute, if you would please, and fill in the domain section. You know the rules. Fill in the domain section. You got these all done? You're supposed to wear it, that's an infraction. All right, do we have these done yet? All right, I need to check our uniform. Make sure everybody's in uniform. All right, here we go. I'm gonna call on random people. Let's see. Xavier, what did you say for this first one here? What did you write down for domain? X what? I think Xavier's right. Do you agree?
He's correct.
And we have to have both of those because the problem has a radical and a denominator. Beautiful work, Xavier. Good job. Okay. How about Eddie? What about this one, Eddie? What did you say that one was?
All reals.
All reals. So negative infinity to infinity. That one's all reals because no denominator, no radical. All right, Alex, what about this one? H.
X is greater than or equal to -5.
Yep, because it has a radical, but that's it, so that's it. Right? Jacob Noix, what about P down here?
X not equal -7.
Yep, and that's the end of that, that's the only answer, done. Okay, how many got it perfect, got that part perfect? That's good, now if your hand isn't up, do you have a question? Did you figure out what you did wrong? Xavier?
I was thinking, I don't even.
Okay. All right, let's look at the next one. Problem A. We're gonna find all of the asymptotes and holes. Jude,
Sorry.
he needs to pay attention, you need to pay attention, right? Okay. So, Sandra, what do you think I should do first? This is problem 2A.
Do I have to, like, put the negatives on the other, on like the numerator?
Well, I'm not sure what you mean by that. Negatives on the numerator, I'm not sure what you mean by that. What? Sandra, if I'm gonna have any holes, what has to happen? What do I have to be able to do if I'm gonna have any holes? Cancel.
Yeah.
Okay, I have to be able to cancel. Now, I can't cancel until I do what first?
Factor.
I have to factor. Does anything in this problem factor? Well, the top does not factor. Does the bottom factor?
Yes.
Into
Plus 1 minus 4.
plus 1 minus 4? Now, does anything cancel? So there won't be any holes. You get points for that, folks. Right, none. Are there any asymptotes? In fact, aren't there 2 verticals? X is -1 and X is 4. How about that horizontal? Very good. I heard somebody, was it you, Eddie, said 0? Because what is the highest power in the problem? But this time, the x squared's in the bottom. So I have to put the 0 on the top. And what's 0 divided by 2? 0. So the horizontal asymptote is y equals 0. Who has a question?
For the vertical asymptote, will like the bottom denominator always be the vertical asymptote?
Yes, because the vertical asymptotes are cannot be's, and x cannot be comes from the denominator cannot be 0. All right, next. Whoa, 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 this is huge. Can we factor anything?
Yes.
All right. Kishad, how does the top factor? Can you factor the top?
Two and three.
So x plus 2, x plus 3?
Yeah.
He's exactly right. I double checked it, I foiled it. Eli, how about the bottom? How does it factor?
Plus 3 minus, wait. Plus 5 minus 3. No, other way around, minus 5 plus 3.
Are we gonna affirm him? He caught himself. Very natural thing to guess wrong. But he caught himself and fixed it. Very good. All right, what do we notice? Can't we cancel? Which means this one is going to have a hole. Now, let's get that position correct. Where is that hole going to be?
-3.
Where x is -3. Now, what's the y?
1.
You gotta plug in here, right? So -3 plus 2, -3 minus 5. So that's -1 over -8. I hear somebody said 1/8. That's it. Now, this is our problem. Now that we've, canceled and all that stuff, this is it. Are there any asymptotes in there anywhere?
Yes.
Well, isn't there a vertical one at 5? And isn't there a horizontal at 1? And I'm very careful to write those as equations. All right, here we go. Do it. Find the horizontal, vertical, asymptotes, and holes for this problem. Come on, you can do it. Go. Think about everything we talked about. Think about how we do this. Come on, Xavier. Kaden, what did you do first?
Kind of faster, but I don't think it did.
Actually, it does. This right here, this does factor. What's the top? It's the difference of squares, Caden. You gotta recognize 16's a square, right? So x minus 4, x plus 4. And can't we do the same thing on the bottom? With 1?
Plus 1 minus 1.
Now, Caden, we did all that factoring, but what didn't happen? No canceling. Which means that there will not be any holes, right? Are there any asymptotes? Well, yeah, aren't there 2 vertical ones? X equals 1 and -1. And is there a horizontal? I think it's easier to see it back here. The horizontal is at y equals 1. Beautiful. We're gonna do one more problem. We're gonna graph our piecewise. and then we'll be done for the day. We'll finish this up tomorrow. Okay? Here we go. Everybody okay with that? Alright, let's do our piecewise, see how far you can get on your own. This is problem 3A. Did you remember to put in a squiggly line at -2? If you forget, it's okay, we're going to erase it later anyway, but without that line, it's hard to know where to put the dots. All right, what shape do I have first? I got a nice little parabola. Is that okay with everybody? Yep, it's gotta be filled in. And I gotta erase part of it. I'm gonna keep that, so get rid of this. What's this? A line dropped down 1. So instead of being that diagonal through the origin, now it's diagonal down here, like this. There's my crossing point. Open. Keep the left, get rid of the right. Go ahead and erase my squiggly line. Got this chunk of parabola over here and this ray shooting down here. Got it? All right, that's it for today. We'll pick up there next time. What I need everybody to do right now is if you are